Okay, so let's talk about proportions. So a proportion is just an equation that is created from two equivalent ratios. So we're still talking about ratios, we're still talking about that multiplicative comparison, but this time, like I said, we're forming that equation from two equivalent ratios. So two things that that mean the same thing, but they look a little different. So in order to create a proportion, we're going to need two things. The first one is we have to have an equal sign. That's what makes it an equation. Equations have equal signs. And the second thing that we're going to need is a variable. Remember, variables are a letter that represents an unknown number. Now, the variable can change for each situation. I normally pick the letter that represents, the object that we're talking about, but we'll look at that as we move on. So when we set up a proportion, we talked about with ratios that order matters. So since a proportion is a ratio, order is still going to matter. So our first example says a recipe that makes 2 pies calls for 10 apples. So if you have 40 apples, how many pies can you make? Write a proportion to solve. So what I typically do is I start with the two things that I'm comparing. And I see here that I am comparing pies to apples. So I'm just going to kind of make myself a little note over here that should be my ratio. I'm going to use a P for pie and an A for apples. And then I'm going to start with the very first ratio that they give me, is that I see that I have 2 pies for 10 apples. Now, since I'm building a proportion, there's one ratio. I have to set it equal to that second ratio. So I know the other number that I know is that I have 40 apples. So I need to make sure that that stays with my other set of apples. So I have to put my 40 down here at the bottom. And then I'm going to use the variable P to represent pies. So this would be my proportion that would help me solve and figure out how many pies I'm going to be able to make. We'll solve it in just a few minutes. We're going to keep going for right now. Our next one says, a mom is creating a balloon arch for her daughter's birthday party. For every 5 green balloons, there are 3 white balloons. So I want to know, how many green balloons will she need if she has 39 white balloons? Write a proportion to solve. So again, the two things that I see that I'm comparing are green balloons and white balloons. So I'm going to use a G for green, a W for white. I'm going to use the first ratio that they give me, which is 5 green for 3 white. I'm going to use my equal sign. And then the other thing that I know is that there are 39 white balloons, and I'm just going to use a G for the missing green balloons. So when I set up a proportion, there are lots of different ways that you can set it up. We kind of have our examples here of our pies and our apples, and you can see that the apples always go together. They're either side by side or they're vertical. Same with the pies. They're either side by side or they're vertical. What we don't want to do is we never want to put apples across from each other or the pies across from each other. So with whatever you're comparing, if I go back to my balloon example, I always want to make sure the greens are next to each other. I wouldn't ever want to put them across from each other. But of course, I have a Smith super secret math hack to help us figure out which proportions are set up correctly. I'm sorry for my pterodactyl. Okay, so it says, in a pack of Starburst, there are 4 red for every 7 yellow. Circle all the proportions that could be used to find the number of yellow Y if there are 28 red Starburst in the pack. So here's how our hack works. I'm going to start with, again, the two things I'm comparing, red and yellow. So I'm going to put an R for red, a Y for yellow. I know that my first ratio is 4 red for every 7 yellow. I'm going to put my equal sign. And then I know there are 28 red Starburst in the pack. And then I'm using the variable Y to represent the missing yellow. So here is your math hack. Since there are so many ways that we could set up a proportion, the one thing that is going to be true in any proportion that you set up correctly is our variable should always be across from the same number. So in this situation, I want Y to be diagonal from 4. So I'm going to look through all of my possible proportions here, and I'm going to circle y and 4. So in this very first one, oh, that's actually the proportion that we set up. So that matches exactly. I know that this one is correct. And the one right underneath it, I have my y and my 4, but this time they are not set up correctly. They're not diagonal from each other. So this is not a good proportion. In the middle one, again, they're not diagonal from each other, so this is not a good proportion. On our top one, this time they're horizontal. They're right next to each other, but they're not diagonal, so it's not a good proportion. And then our last one, they switched places, but they're still diagonal from each other, so this is a good proportion that we could use. Looking at our next one, it says Rachel is making cupcakes for Winston. The recipe calls for 7,500 cups of honey for every 12 cupcakes. Circle all the proportions that could be used to find the amount of honey, H, that Rachel will need to make 24 cupcakes. So the two things that I'm comparing here are honey and cupcakes. So I'm going to put an H for honey, a P for cupcakes. I know that I'm going to need 7,500 of a cup of honey for every 12 cupcakes. She wants to make Winston 24 cupcakes, and H is going to represent the honey. So again, look diagonal from your variable. I see that H should be across from 12. Well, it looks like I made a mistake in here. Those X's should all be H's, but that's okay. Still a variable, still representing an unknown value. So in the very first one, 12 and X are right next to each other, so that's not a good proportion. And our next one, this is actually the proportion that we just set up over here on the side. They are diagonal from each other. This proportion would help us solve. On our next one, X and 12 are diagonal from each other. This would be a great proportion for us. Our next one, X and 12 are right next to each other. Not a good proportion. And then our very last one, X and 12 are diagonal from each other. This is a good proportion. So again, that is our Smith Super Secret Math Hack. Just look for what is diagonal from across your variable. It should always be the same no matter how you set up your proportion. All right, going to the back. Now we're going to look at how do we solve this proportion. What are we looking for here? So our problem says that the recipe that Sylvia is using says 10 apples are needed for every 2 pies. How many pies can she make with 55 apples? So again, I'm going to set up my proportion. The two things that I am comparing are apples and pies. So I'm going to do an A for apple, a P for pies. My first ratio is that there are 10 apples for 2 pies. And that's going to be equal to, she has 55 apples, but I don't know how many pies. That's what I'm looking for. So now that I've got my proportion set up, I'm looking for my scale factor. And remember, there are 2 places that I can find a scale factor. I can look within a ratio, or I can look between 2 ratios. Now, the one that jumps out to my eye first is I see that I can do 10 to 2, and my scale factor there would be divided by 5. What I do to one side, I have to do to the other side. So 55 divided by 5 would give me 11 pies. Okay, so this scale factor took us within. Let's see what happens when we have a scale factor that goes between. So same thing, she has 10 apples for 2 pies. So I'm going to set up my proportion again. Apples and pies, 10 apples, 2 pies. But this time I want to know how many apples are needed for 6 pies. Now again, I could still use that same ratio of 10 to 2, but for the sake of our notes, I can also go between the ratios this time and go from 2 to 6. My ratio, or excuse me, my scale factor would be times 3. What I do to the bottom, I have to do to the top. So 10 times 3 would give me 30 apples. That's how many she would need to make 6 pies. Okay. Then our next one says, yesterday, Melissa rode her bike 4 miles in 14 minutes. And her goal today is to ride her bike for 70 minutes. So if she travels the same rate, how many miles will she travel in 70 minutes? So the two things that I am comparing here are miles and minutes. So I'm going to write these out because they both start with M. Oops. And they both start with MI. So I'm just going to write it out. So we'll do miles and min. Okay, my first ratio is 4 miles in 14 minutes. And that's going to be equal to if she's riding her bike for 70 minutes. Okay, now sometimes we run into an issue where when we look at a ratio, there's not really a great scale factor that jumps out to us right away. Like there's not a good one within to go from 4 to 14, and there's not a good one to go between from 14 to 70. So what you can do is if you don't see a good scale factor, try simplifying the ratio that you do have. I see that I can simplify 4 and 14. They both have this factor 2 in common. So that would become 2 miles in 7 minutes. And when I do that, scale factor jumps out to me and I say, okay, well, I can do 7 times 10 gets me to 70. What I do to the bottom, I have to do to the top. So 2 times 10 would give me 20 miles. Our next one, number 4, says at the Sci-Fair candy shop, 2 pounds of chocolate cost $1.52. At this rate, how much would 5 pounds of chocolate cost in dollars and cents? So the two things I'm comparing here are pounds and money. So I'm going to do LBS for pounds, just the dollar sign for money. So I have 2 pounds for $1.52, and I want to know how much would 5 pounds cost. Now, I know when we look at this that we could find a scale factor. I have one within and I have one between, but I want to see what would happen if I didn't really see those scale factors. What could be another option if I'm like, oh, I don't know what my scale factor is? And the next option, instead of simplifying, is I can find, remember, what's called our unit rate. So our unit rate is what happens when one of our values, one of our problems, has a value of 1. So if I have 2 pounds, let's see if I can figure out what just 1 pound would cost. So to go from 2 to 1, I'm dividing by 2. So I need to do $1.52 divided by 2. So 2 can't go into 1, but 2 goes into 15 7 times. And then 2 will go into 12 6 times. So 1 pound of chocolate costs 76 cents. And then I can use my scale factor to go from 1 to 5 would be times 5 times 5. So 76 cents times 5 would be 6 times 5 is 30. So write the 0, carry the 3. 7 times 5 is 35 plus 3 more is 38. My decimal needs to get moved 2 places for $3.80. Now, again, that was just one way to solve it. It's an option if you don't see that second, or if you don't see either of the scale factors. But when we do proportion, there are lots of different ways that you can solve a proportion. It's just what your brain sees first.